Hello, good evening, my dear students. So, you are on Unacademy NEET Elixir channel, and I am your very own Anoop Vashishtha, and here we are with the remaining part of the chapter called Surface Chemistry. Am I audible and visible to all of you? Can you hear me and see me? Yes, I'm audible and I'm visible, and you can absolutely see me. No confusions, no problems. Today we are having a class at a very different time. It is 9 p.m. and nowadays we are going to have lot many marathons because as you very well understand this concept of backlog. Who else will be knowing the backlog better than you all? So, am I audible to all of you? Anyone has any kind of confusions here? Any kind of missing part? Everybody is able to see me and hear me? So, let's have it a little better. I'm not able to see your comments very clearly. What do we do? Okay, fine. Today we are going to make do with this particular part. Okay, perfectly fine. So your comments are also now visible to me. So let's get along with it. We are going to talk about the chapter called the surface chemistry, and here we are going to talk about the topic called the colloids. So let's get along with the topic called the colloids. First of all, let me tell you about myself. My name is Anoop Vashishtha. I am an MSc in chemistry from University of Delhi, 26 plus years teaching experience. Lakhs of students have been taught by me. Many of the students have become doctors, engineers, and some even have become teachers. So, to get along with it, let's begin over with the topic called colloids. Now, when we talk about the colloids, here is a quite typical concept. So, let's talk about the concept of the colloids. Okay, so to begin over with, the concept of colloids. Hmm. When we talk about the colloids, there are certain things like we have solutions and we have suspensions, and then we have the colloids, solutions, suspensions, and the colloids. To talk about them, okay, Kota, Rohit, Abba, Harshit, Ran, sir, आप पर class कब start करोगे? Because I am an academy offline students waiting for your course. Beta, the app class is going to start from 24th of January. We have already launched the course. It is going to be online on 24th of July. Why am I calling January? It's 24th of July. Okay. So when we talk about the two extremes, we have something called the solutions. Here we have something called the solution. When we talk about the solution, the code, the difference, the link, the range is when we have the particle size is less than 10 angstrom. When the particle size is less than the 10 angstrom, then in that case we call it a solution. When the particle size is greater than, we have suspension. Suspension means the particle size is greater than, let us say, 10,000 angstrom. That is, we have 1 nanometer, and we have 1000 nanometer. So this is what we have as 1 nanometer and 1000 nanometer. If it is less than 1 nanometer, then in that case, it turns out to be the solution. If it is greater than 1000 nanometer, then it turns out to be a suspension. And in between the 10 angstrom and 10,000 angstrom, there is a range which is called the colloid. So the colloid is the range in between the solution and suspension. So that is what we have a term called the colloid. This is what we have the difference between solution, suspension, and colloid. Colloids are not some different matter. They are not even some state of matter. They are simply the state of division of the matter. If we have very fine division, then in that case it becomes a solution. If we have coarse division, it becomes a suspension. And somewhere in between, we have a thing called the colloid. Ananya, what exactly is your doubt? Simply ask it. What is your doubt? Ananya, ask me the doubt. Don't think over it, just ask the doubt. So that is what we have as colloids, and these are the colloidal systems that we have. Now, having talked about this particular part, so I have just given you the answer. The size of the colloidal particle is, could you just give me the answer of it? What is the size of the colloidal particle? No answer. What happened? Schedule. Schedule is already shared with you. 3 p.m. that is the zoology class and 4 p.m. is the chemistry class. We are at this moment doing the chemistry of 11th and 12th. 3 days we have the 11th class chemistry, which we are doing the states of matter, and 3 days we have the 12th class chemistry, in which we are doing the solutions chapter. Very soon we are going to finish off the solution chapter, having the marathons. I believe tomorrow we are going to complete the states of matter. No, tomorrow we are going to complete the solution chapter. We are going to have again the 2 classes of solution chapter in the afternoon and in the evening, so that we are going to finish off with the solution chapter, and we are going to have the states of matter chapter we are going to complete day after tomorrow. So a bit rapid sequence is going to go on. So what's the answer? The size of the colloidal particle is? And then the desorption is reverse of adsorption or the absorption. It is the separation of the adsorbent and adsorbate. That is what we call as desorption. Okay, that's what we have already discussed in today's class. In the afternoon, we discussed about the desorption, adsorption, absorption, and all. So you got the answer? That is from 10 raised to power minus 6 to 10 raised to power minus 9 meter. That is 1 nanometer to 1 micron. That is the size of the colloidal particles. Is that clear? When we talk about the colloids, it consists of 2 parts. One is called the dispersed phase and other one is called the dispersion medium. When we talk about its classification, when we talk about the identification of the dispersion phase and the dispersed medium, it is absolutely simple. It's absolutely straightforward. What is Le-Chatelier principle of reversible nature? Le-Chatelier principle simply says that whenever we increase the concentration of one substance, that is being consumed, and other substance which is less in quantity, that is being formed. Okay, so let's talk about the dispersed phase and the dispersion medium. So when we talk about the dispersed phase, Okay. So when we talk about the colloids, we are talking about the two different parts. One is called the dispersion medium, another one is called the dispersed phase. Muhammad Tahir Nazir says, you are outstanding man. Does it mean that I have always been standing outside of the class? It's not 1000 angstrom, it is actually 10,000 angstrom. Sachin sir is asking me, where are you? So I am telling him that I am in the class. So here we have the colloids. Now colloids is consisting of two parts. One is called the dispersion medium, another one is called the dispersed phase. Amritpal Singh, pehchana. Beta, it has been a joke, early joke that pehchan kaun, pehchana, pehchan kaun. Tell me. So here we talk about the dispersed phase. Dispersed phase is the phase which is in less amount, while dispersion medium is the one which is in the excess amount. You can even say that dispersion medium is the one which is actually linked, while dispersed phase is the one which is separated. So that is the difference between the dispersion medium and the dispersed phase. Which one is Pravit Srivastav? What about organic chemistry? The organic chemistry is going to start in the plus courses. So in plus courses, we are going to start the organic chemistry. That is going to start from the organic chemistry very fast. Syllabus itna fast क्यों sir? Pravit, what is the month today? Today the month is what we call as July. If you are in 12th class, then you would like to finish off the course, entire course by December. If you are 12th pass, then in that case, you would like to finish the course by 7th of May, or in fact, the 1st of May with complete revision and questions. We have 30 chapters of chemistry. What do you expect me to do? Okay. So here what we have is we have the less amount is a separated substance, separated. It is not dispersed. Dispersed phase is not in contact with itself, while dispersion medium is actually in contact. Date for organic 24th of July. We are going to start the organic on the plus courses. So you'll have to take the subscription for that. Okay. I'll very soon launch the course and then you can take the subscription for that. So that's what we have as the dispersed phase and dispersion medium. There are so many possibilities, so many parts which we can have as the dispersed phase and dispersion medium. Now, the very first thing you need to understand that we can have the classification of colloids. Now, dispersed phase is the phase that is dispersed present in the form of colloidal particles, that is in lesser amount. As far as solute and solvent is concerned, you can loosely consider it to be the solute. Okay, Pravit, as far as I'm concerned, I consider the thing to be fast if you are not able to understand it. If you are perfectly able to understand it, that simply means I am going absolutely slow. So if you are not able to understand something, you can simply ask me. But if you are able to understand everything, I'm going quite slow, isn't it? Leaved. I am in Unacademy NEET Elixir at this moment. But I am always with you. That you need to understand. So that's what we have as the phase that is dispersed present in a small amount in form of the colloidal particle, while dispersion medium is the one in which that phase has been dispersed. It is spread. And dispersion medium is the medium which is in excess amount, huge amount. That is what we call as the dispersion medium. Now here we have the colloids. So colloids is actually dispersed phase plus the dispersion medium. There are so many examples of colloid in everyday life. Smoke. Smoke is actually a colloid. We talk about clouds. Clouds are colloids. Smog is again a colloid. The tinted glasses, they are colloids. So all these substances are colloids. So every day we are having so many examples of colloid. Mist, fog, all these are colloids. Is that clear? So in this case, when we talk about the gold sol, the solid dispersed in a liquid is termed as a sol. So this is what we have as the gold sol. Considering the gold sol has water as the dispersion medium. So here, dispersion medium in the gold sol is water, while dispersed phase is actually metallic gold. So that is what we have as the gold sol. Aditya, we are going to teach organic also in YouTube. But what we are doing is we are initially starting the course on the plus courses. And before that, we are going to have the special classes so that you can get a feel how YouTube is different from the plus courses and what exactly is the benefit of the plus course. Okay? If you want to study free, it's absolutely free, absolutely not a problem. You can study from YouTube. And yes, YouTube is a two-way communication as far as I am concerned. So let's talk about the classification of colloid. There are so many ways to classify the colloids, but the very first way of classifying the colloid is depending on the classification according to the dispersion medium and the dispersed phase and the dispersion medium. So we are going to classify the colloids based on physical state of dispersed phase and dispersion medium. And then we are going to talk about the nature of interaction between dispersed phase and dispersion medium. What is the interaction between the two? And then we are going to talk about the different types of particle which we have in the colloid. Let us get along with the physical state of dispersed phase and dispersion medium. Now, to talk about the physical state, obviously we have the three physical states. We have solid, liquid, and gas. So we can have dispersed phase in these three states, and similarly dispersion medium also could be in these three states. Ideally speaking, we have three dispersion medium state and three dispersed phase state, so we should be having 9 types of colloid. But there is a problem, and that problem is that gas plus gas is never a colloid. Gas plus gas is always a solution. So gas plus gas does not give us a colloid, it gives us a solution. So gas plus gas does not form a colloid. So that is not a possible combination to form a colloid. Is that clear? Jeete raho beta Rahul, how are you? Ananya, we can get a question from the diagram as well, and we are going to do all the diagrams. So don't worry about it. Is it clear? So all the students who are there, have you liked the session? Go ahead and like the session. Don't be cringy on liking the channel. So here we have the first classification. The dispersed phase is a solid and dispersion medium again is a solid. And that is what we call as a solid sol. Many of the gemstones, the tinted glasses, maybe you have been in a restaurant and maybe even in your house, you have tinted glasses, that purple colored glass, the blue colored glass. Those all glasses are colloids in which solid is dispersed in a solid. Is this clear? Arman, you have been able to understand this? That's great. So you like it. So that is what we call as a colloid. This is a solid sol, solid colloid. And then here we have the dispersed phase being the solid and dispersion medium being a liquid. So these are most of the paints, the lacquers, the various other colloids. So these are what we simply term as the sol. So solid dispersed in a liquid is simply termed as a sol. So that's another classification. And then we have the solid or liquid dispersed in a gas. So here it could be solid or here it could be a liquid also. In both these cases, when the solid is dispersed in a liquid, the solid or liquid is dispersed in a gas, it is termed as aerosol. And the typical example of that is cloud. Cloud is an aerosol. The smog, it's an aerosol. Fog is an aerosol. So these are the particles, liquids and solid particles dispersed in a gas. So that is what we have as a term called a sol. And then we have the liquid dispersed in a solid. Liquid dispersed in a solid. Butter. Okay. Cheese. That is what we call as a gel. Please be very clear. Liquid dispersed in a solid is termed as a gel. Okay. Go ahead and follow Aditya. That won't be a problem. राहुल सर अगर इंग्लिश मीडियम से होता तो आपसे पढ़ने का सौभाग्य प्राप्त कर पाता but I am understanding. You are understanding, so what's the problem, Rahul? If you want, I can go a little slow, but please understand, Rahul, one thing you need to understand that when we talk about the English medium or Hindi medium, even if I try to speak in Hindi and I explain it everything to you in Hindi medium, still, when you are in MBBS, you will have to cope up with English medium. Why not start today itself? Okay. And I'll be make it very clear and I'll make sure that you are able to understand everything. Is that clear? Then we could have liquid dispersed in a liquid, and that is an extremely broad range, and that is what we call as emulsions. Many of the things are emulsions, like milk. Milk is an emulsion. And many of the medicines are in the form of emulsion where we have liquid mixed with a liquid. The fat dispersed in water, the liquids which are not actually miscible with each other. That's what we have as the emulsion. One thing you need to understand that colloids are formed by the substances which are not actually soluble with each other or miscible with each other. If the substances are soluble with each other, they are not called colloids. They are referred to as crystalloids. So we have the classification. One is called the colloids and another one is called crystalloids. Hey, why are we not able to see it? Okay, let's have it. So we have something called crystalloids. Crystalloids are the substances which are miscible with each other, or you may term it as soluble. Colloids are the substances which are sparingly soluble or which are not miscible with each other. Like when we talk about liquids with liquids, we talk about the term called miscibility. But when we talk about the solid in the liquids, we call about solubility. When we talk about gases, gases are always soluble with each other. Now, here's a confusion, isn't it? Clear? So all those students who are watching at this moment, have they liked the session? So that's what we have as the crystalloids and solubility. And then we have again liquids in a gas. That again becomes an aerosol. I told you that solids in a gas or a liquid in a gas is what we term as the aerosol. So this is what we have as a classification of the colloids on the basis of the physical state of dispersion phase and the dispersed medium. So this is what we have as the classification. And here we have something called the solid sol. We have the dispersed phase as the gas and the dispersion medium as the solid. It is termed as again the solid sol. Okay. Earlier it was termed as solid foam, but fine enough, solid sol. But if the liquid, the gas is dispersed in a liquid, it becomes the foam. Jhag. Clear? And you would have seen the foam so many times. And we do have those foams, the acrylic foams and all. Of course, that also is a foam. Is this clear? So this is what we have as the various phases like solid, liquid, and gas. Dispersed phase solid, dispersion medium is solid, then it becomes solid sol. If dispersion medium is liquid, it becomes sol. If it is gas, it becomes aerosol. If we have the dispersed phase as liquid, if it is in solid, it's gel. If it is in liquid, it's emulsion. If it is in air, it's aerosol. If the gas is dispersed in a solid, it's solid sol. If it is in liquid, it's foam. Gas in gas is not a foam, it's a solution. Is that clear? Now we are going to talk about the classification of the colloids on the basis of the interaction of the dispersion medium and the dispersed phase. Now, when we talk about the particles, when they are in close proximity with each other, they have to have some interaction. Close proximity. That means they are near to each other. Kindly do a session on suspension emulsion as well. Of course, Muhammad Tahir Nazir, we are getting along with suspension emulsion and the colloids. When you talk about emulsion, it is a colloid itself. And suspension, we don't need to do a different session altogether because suspension is simply where the particles are visible. Is this clear? So when we talk about between the nature of interaction, we have lyophilic colloids and we have the lyophobic colloids. Lyo means the dispersion medium. Lyo means the dispersion medium. And here we are going to talk about the dispersion medium as the liquid. So here we call it as lyophilic. Lyophilic is liquid attracting or the dispersion medium attracting colloids. Those are what we call as lyophilic. And then we have lyophobic, that is, they do not interact with each other. That is what we call as lyophobic. Now you would be surprised what exactly is the meaning of lyophilic and lyophobic. When we talk about the lyophilic colloids, it simply means that the dispersion medium and dispersed phase, they interact with each other so that their interaction is strong enough to break the attractive forces between the dispersion medium and dispersion medium, dispersed phase and dispersed phase. So the net attractive force is between the dispersion medium and dispersed phase particles. So please understand that whenever we are mixing two substances, we have to break certain interaction and we have to form certain other interaction. Like we have the dispersed phase interaction. We have the dispersion medium interaction. So if dispersed phase and dispersed phase interaction needs to be broken, dispersion medium interaction needs to be broken, and we end up with a dispersed phase and dispersion medium interaction. If dispersed phase dispersion medium interaction is more than the dispersed phase dispersion medium interaction, then in that case, when these kind of colloids are formed, it is going to be actually an exothermic process in which energy would be released, the energy consumed would be less, energy formed would be more, released would be more, and we are going to have a lyophilic colloid. Is this clear? Have I made it very clear what exactly is the meaning of the lyophilic colloids? On the other hand, if the dispersion medium interaction, dispersed phase interaction is greater than the dispersed phase, the dispersion medium interaction, then in that case, we will have to make an extra effort to make this colloid. Now, please remember that when we are talking about the colloidal formation, we are dispersing the system. Clear? And here, this system is going to be endothermic and it's going to be quite unstable. So that is what we have as the lyophobic colloids. There are so many examples of lyophilic and lyophobic colloids, and there are so many properties of these colloids. Let's get along with something called the lyophilic colloids. Lyophilic, lyo means liquid, philic means attracting. That is, the attractive forces are greater. The colloidal systems in which the particles of the dispersed phase have a great affinity for the dispersion medium. That's what I have already explained to you, that they have a very great affinity. So what we find is that dispersed phase has a layer of the dispersion medium on its surface. So a layer is formed and the dispersed phase is separated from each other. The particles of the dispersed phase are separated from each other by the layer of the dispersion medium that sticks on the surface. So that is what we have as the lyophilic colloids. Any confusion? Anything you would like to ask? I hope you have all your pens, papers, NCERT book, and you are creating the notes along with it. Okay. So these are the systems in which the colloidal systems, the particles of the dispersed phase have a great affinity, so that form their layer. There are so many examples of that. Like in water, if we talk about the carbohydrates dispersed in water, they form a lyophilic colloid. Proteins dispersed in water because they are capable of forming hydrogen bonds with water. So proteins, when we talk about the carbohydrates, they form a lyophilic colloid. Anybody has to ask? Buffering? No, absolutely not. And then from my side, it's not buffering because I'm watching this particular session on the YouTube as well, and I'm not finding any buffering taking place. I perfectly understand that this particular session is delayed by about 20 seconds. So there's a lot of delay in between, but that's not buffering. So when we talk about the lyophilic colloids, there are so many examples: glue, gelatin, starch, proteins, egg albumin, rubber. These are all lyophilic colloids. All the students who are there in the session, have they already liked? So just like the session. So that's what we have as lyophilic colloids. Now we talk about the properties of lyophilic colloids. The very first thing, when you talk about lyophilic colloids, the very first properties are these are very easy to prepare. They are very easy to prepare. Now, what's the ease in its preparation? Most of the times it's enough to mix the dispersion medium and the dispersed phase along with stirring and a little bit of heating. Because here also we need to break the interactive forces between the various particles. So a little bit of energy is required, not too much, but a little bit of energy is required. So you just shake it well and you are able to get the lyophilic colloid. Similarly, like in starch, you can easily make the colloid of the starch many a time. Nowadays, the starch is available in market where you just need to cut the packet, just dissolve it in warm water, shake it with, and you are going to get a starch colloid. Okay, so it is extremely easy to prepare. Second, it is easy to store. That is, it can be stored, it can be kept for a long duration. It does not actually coagulate. Clear? And then there is another property which we call as reversible. Now, what is the meaning of reversible? I would just give you an example. Many of the students, they would have got a polypack milk. Maybe you have one or the other time in your life, you would have seen a polypack milk, Amul, Nandini. Depending on wherever you're staying, you might have a different company providing you the polypack milk, Madhusudan, and so on and so forth. Now, when we talk about those milks, sometimes it so happens that you take the polypack, you put it in your fridge, and rather than heating the milk right at that time, you might delay it to the next day. When you delay it for the next day, you would find that when you pour down the milk from the polypack into the container where you boil the milk, you would find that some part of the cream is sticking on that polypack. Now, there are many ways to take out that cream. One, you can simply put the warm milk in that polypack, shake it a bit, and just pour it down, that entire cream sticking on the surface of the polypack from inside is going to go along with the hot milk. Or you can add a little bit of water and you can just shake it. And you need to have it a little warm. The cold water won't be able to do it. Now, this gives us an idea that when we talk about colloidal formation, colloid formation, then in that case, the system must be at a specific temperature for the colloid to be formed. Okay, at a very low temperature, the colloid won't be formed that easily. That's going to get coagulated. Is this clear? So now, what is this? Here, the substance has settled down. The dispersed phase has settled down, but we added a bit more of the dispersion medium and converted that dispersed phase back to the colloid. Is this clear? So that is what we know by lyophilic colloids and their reversibility. The lyophilic colloids can be reversed. Is this clear? Where are the other students? They are moving away. So this is what we have as the lyophilic colloids. And there is another very peculiar property of the lyophilic colloids. They can act as protective colloids. Not only they are stable, but they have a capacity to stabilize the non-stable colloids. And that is how they act as the protective colloids. Is this clear? And when we talk about the protective colloids, here we get something called the gold number. Gold number is the milligrams of the protective colloid that need to be added to prevent the coagulation or deposition of the 10 milliliter of the gold sol when 1 milliliter of sodium chloride 10% solution has been added to it. Please remember, the gold number as such is not in your course. It has never been asked in any of the entrance examination. It's not given in NCERT. So I don't think so that gold number is going to be asked in your exams. You just need to do one thing. You need to remember just one thing. The protective power of a colloid is inversely dependent on the gold number. Means protective power is inversely dependent on gold number. As you can see with the definition itself, the gold number actually talks about the milligrams of the colloid. So if we have a higher gold number, that simply means that we have to add more amount of protective colloids. So more amount of protective colloid that we need to add, that simply means its protecting power is that much lower. Any kind of doubts? If anybody has, there are only 11 students watching here. In fact, out of those 11, one is myself. So there are only 10 students watching me, and 10 students would be simply like an individual class. So you can ask all your doubts right here, and I'll be able to solve it. So the speed of the class will be decided by you, not by me. Is that clear? So this is what we have as protective colloids and their protective power. That is inversely dependent to gold number. Now, to talk about the lyophobic colloids. Lyophobic colloids are those substances which do not have any interaction with the dispersion medium. Something like, let us say we talk about metals being dispersed in oil or maybe water. Now, metal is not able to form any kind of hydrogen bonds with water. The metal is not able to form any kind of ion dipole interaction with water. So, if I want to put the metal in water, then in that case, it will try to break the hydrogen bonds of water while not forming any bonds with it. So, it is quite going to be difficult. And that is why water would like to have kind of, there is some person whom you don't like, but you ignore that person. So that person simply fits in a cavity somewhere and you simply ignore that person. It's something like a rock being put in a stream. The stream goes around the rock rather than being with the rock. So that is what we have as the lyophobic lyophobic colloids. Something like oil in water. Oil in water is not lyophilic, that is lyophobic. Oil wants to separate from water. It's quite understandable that lyophobic colloids are going to be difficult to form. Okay, so that's going to be difficult to form. And to form the lyophobic colloids, we have certain very specific methods. Okay, so there are certain specific methods to form lyophobic colloids. They are not formed by just mixing the things. Many a times we have to add the stabilizing agent, and that stabilizing agent again is going to be a lyophilic colloid. Now, lyophobic colloids are difficult to form. They easily settle down. And once they settle down, they do not go into the colloidal phase that easily. We'll have to do the process once again. Then only they will be able to go in the colloidal phase once again. Is that clear? So that is what we have as the lyophobic colloids. And quite obviously, these are irreversible. Once they settle down, they do not go back into the colloidal state. Is it clear? And there are so many examples of these, like gold sol, like oil in water. Clear? All the metal salts, these are lyophobic colloids. Is that clear? So, which of the following is a lyophobic colloid? I believe I have already given a solution, given the answer. So, which one of these is a lyophobic colloid? Answer. Quick, quick, quick. Could we get the answer quickly? Ananya, tell me what would be the answer here? I just told you. I don't know. There are so few students, but they are so lazy giving the answer. That should not be gold solution. That should be gold sol. Now that's a lyophobic colloid. Is that clear? Fine. Okay then. So that's what we have as lyophobic and lyophilic colloid. Now we are going to talk about the classification of colloids on the basis of the types of the dispersed particles. That is, what kind of particle is being dispersed. And on the basis of that, we have multimolecular colloids, macromolecular colloids, and associated colloids. Now, the name itself tells you about the nature of these colloids. Like when we talk about multimolecular colloids, the multimolecular colloids are the ones in which the particles of the substance that we have dispersed are quite small. They are not large enough to form a colloid. So many of the particles merge together, they join together to form a particle which is large enough to be a colloidal range and not large enough to be in the suspension. So it is somewhere in between the solution and the colloid, and many particles merge together to form the colloidal particle. So that is what we have as the multimolecular colloid. These are forming the aggregates. Clear? So that's what we have as multimolecular colloid. When we talk about gold sol, it is going to be a multimolecular colloid because many of the gold particles are merging together to form the colloid. We have silver chloride sol, we have arsenic sulfide sol. These are multimolecular colloid because individual particle is not large enough to be in the colloidal range. Now, next we talk about something called the macromolecular colloids. Now, examples are multimolecular colloid, gold sol, then sulfur sol, and now to talk about macromolecular colloid. The word itself is macro. Macro means large. Each particle of the substance is large enough to be in the colloidal range. It does not need to associate or join together with any other particle. The example, obviously example, the starch. Starch is a large molecule. So each molecule of starch is going to be in the colloidal range. Similarly, when we talk about proteins, proteins are large enough to be itself in the colloidal system. That is why we never call starch solution, because starch is not going to form solution. Starch is always going to form colloid. In the same manner, proteins, they are also going to form colloid and they will never form the solution. So that's a typical thing about the colloids. Now I can actually show you that blood is a colloid. Now, the thing which we know, the experiment that we do is the Tyndall effect that shows us the difference between solutions, suspensions, and the colloids. So macromolecular colloids, we have already understood the starch, protein, the macromolecules. The size of the macromolecules are in the colloidal range. Is this clear? Polythene. Ananya, polythene in what? Polythene itself is a substance. It is not in itself a colloid. So what are you going to put polythene in? Pragati Padole says, what's your name, sir? My name is written right in the description of the YouTube. Just see the topic and you will get my name. Clear? So that's what we have as the macromolecular colloid. Starch, cellulose, enzymes. A polythene, when it is suspended in a particular solvent, maybe carbon tetrachloride, or maybe there are certain substances which are able to dissolve polythene. Nylon, polystyrene, synthetic rubber, they, when dispersed in a system, they form the colloids. And then we have associated colloid. Now, associated colloids are a very peculiar system. These are bipolar substances. They have a polar head and a non-polar tail. So they have a polar head and a non-polar tail. That's how they become bipolar substances. Clear? So it is not a compulsion that these substances need to be charged. The only thing is they need to have a polar head. Now, polar head could be anything. Polar head could be OH. Okay. Polar head could be NH2. Polar head could be maybe SH, maybe COO minus, maybe SO3 minus. It could be anything. And the non-polar tail could be a hydrocarbon. It could be a hydrocarbon, isn't it? Hydrocarbon is always non-polar. Hydrocarbon could be having benzene, or it could be simply carbon chain. Is it okay? It's written man-made colloids. Fine enough. Colloids could be man-made. Colloids could be natural. And when we talk about soap, please remember, it is not a thing like soap is always artificial, or these kind of colloids are artificial, associated colloids. Many of the people would have learned that there are so many things which we use to wash hair. I would think you would be some Ayurvedic shampoos, Rita, Amla. That Rita, if you can get hold of this Rita, you simply boil it in water and you are going to get a detergent, a soap. Clear? So Rita in itself is able to give us the soap. And initially in India, many a times people tend force you to believe that this kind of a soap or this kind of detergent were something which were given by Britishers to us. But the fact is that Indians had been using this Rita as a natural detergent since very long time. Okay, so that's what we have as the polar heads and non-polar tails. Clear? Anyone who has not liked the session as yet, go ahead and quickly like the session. Class PDF is going to be available on the group. Okay, and I would sincerely request you to make your own notes. Just add the informations, whichever extra information is there, right? Add it right in the NCERT book. And as far as chemistry is concerned, you actually don't need any extra information. Is that clear? So that's what we talk about, the associated colloids. Associated colloids, these are peculiar substances. They, at low concentration, they become true solutions because the particles are not large enough to be in the colloidal range. Single particle is not large enough to be in the colloidal range. And the individual particle has a capacity to form attractive forces with the dispersion medium. So in a low concentration, these substances form true solution. But when the concentration becomes more than a specified limit, and that specified limit is called critical micellization concentration. So when the concentration goes beyond the critical micellization concentration, they become colloids. Below that, they are simply the solutions. And there is a specific temperature as well. Below a certain temperature, it will never go to the critical micellization concentration. And below that specific temperature, it is only going to form a solution. It's not going to form a colloid. That specific temperature is called the Kraft's temperature. The temperature below which the colloid will not be formed. It will remain a solution is termed as the Kraft's temperature. Is it clear? And the concentration below which it behaves as a true solution is termed as critical micellization concentration. And as I have just said, you would have understood that these colloidal particles are termed as micelles. Is this clear? So that's what we have as the associated colloids, and they are called micelles. Examples are soaps, detergents, and there are so many different types of soaps and detergents. There are certain anionic soaps, anionic detergents, there are cationic detergents, there are neutral detergents. The only thing is that they need to have a polar head and non-polar tail. Is this clear? So that is what we term as the associated colloids, the micelles. Micelles are the small spherical structure which are formed by 100 to 200 molecules joining with each other. Individually, these molecules are not large enough to be in the colloidal range, but they form a cluster, they form an association, a specific arrangement to form the micelles. When we talk about the micelles, micelles are always having a head, which is lyophilic in nature, and then there is a tail, which is lyophobic in nature. So these micelles, they join with each other, forming a small spherical structure. The non or lyophobic tails, they are within the micelles while heads are on the surface. Class 12 passed, so class 13 school to go. Critical micellization concentration is the minimum concentration that must be achieved for micelles to be formed. Below this particular concentration, micelles will not be formed. Is that clear? Any confusions? So that's what we have as the micelles. Soap solution. I would say soap colloid. Okay. Soap is a sodium salt of a high fatty acid, which is represented as like this. Okay. Long chain fatty acids. So that creates a soap. Snehal Patel, lyophilic or hydrophilic. If the dispersion medium is water, then in that case we use the word hydrophilic and hydrophobic. But it's not necessary that in all cases of colloids, the dispersion medium needs to be water. So it is not necessarily hydrophilic or hydrophobic. It may be lyophilic. Okay. Any kind of doubts? So we have hydrophobic or lyophobic part and lyophilic part. My class 13 school to go. Football, I am not able to understand what exactly you are trying to say. Okay. So this is what we have as the micelle formation. Clear? So here we get the beautiful micelles which are being formed. Jatin, you haven't got the PDF because I haven't sent it as yet. I'll send it because I have to create those sessions, isn't it? Today you are going to get the Telegram channel, the group here, the notes here. This is already we have discussed how the micelles are being formed. Ashutosh Chaurasia, yes, I was for a long time. I was not on Unacademy, perhaps 10 months. No, not 10 months, more than that. The last class I had on Unacademy was on 31st of May 2022, or even before that. Clear? Now we are going to talk about the preparation of colloids. As I have told you, when we talk about the lyophilic colloids, we don't have to have certain very specific methods of preparation. We can easily prepare the colloids. But when we talk about the lyophobic colloids, for that, we need to have very specific methods. We can have the chemical methods, we can have electrical disintegration, we can have the peptizations. So let's get along with the chemical methods. When you talk about the chemical methods, that could be the oxidation reaction, that could be reduction reaction, that could be the precipitation reactions. So many different reactions could be there to create the chemical methods. Okay, oxidation, reduction, etc. Clear? Something like we have gold chloride. So if gold chloride is reduced, remember that gold is a noble metal and it tries to remain in the atomic form, the metallic form. So gold compounds, they are good oxidizing agents. We can have certain substances which are easily oxidized, something like aldehydes. Aldehydes are easily oxidized. They are quite easily oxidized. So when we are adding aldehydes to a gold chloride solution, those aldehydes are able to get oxidized themselves and reduce gold to form the gold particles. Now, these gold particles are not large enough to be precipitated. They are not small enough to be in solution, so they go into the colloidal range. So this is the reduction method by which we can create the colloids. And then we have the double decomposition. We have arsenic oxide and in arsenic oxide, we bubble as hydrogen sulfide. This hydrogen sulfide is going to form the arsenic sulfide. Arsenic sulfide particle is not too big. This arsenic sulfide particles, they join together to form a cluster. That cluster is within the colloidal range, and this forms the colloid. So that is what we have as arsenic sulfide sol, and this is double decomposition. Then we could have the oxidation. Hydrogen sulfide becomes the reducing agent, sulfur dioxide becomes the oxidizing agent, and they together form the sulfur which gets into the colloidal system. This can also be if we have, you would be knowing, I don't know whether you have done the inorganic salt analysis or not. When we make the solution of the salt, that is never made in nitric acid. We may make the solution in hydrochloric acid, we may make the solution in water, but we don't make the solution in nitric acid. Although all metals are soluble in nitric acid and all metal nitrates are soluble. Why don't we make the solution in nitric acid? The simple reason is that if we make the solution in nitric acid, then in that case, if we pass hydrogen sulfide through it, then nitric acid is going to oxidize hydrogen sulfide to form sulfur colloid. And that sulfur colloid, if it is formed, then you will not be able to see the precipitate which is formed. Is this clear? Anushka, when we talk about ethanol, ethanol is not going to form the missile. Keys to success beta, this is not a bilingual channel. This is a English channel. So we are going to teach in English in this channel. Okay. We have only got 26 likes. Where are the other likes? Okay. And then we could have simple hydrolysis reaction, like we have iron chloride, ferric chloride, and we add ferric chloride dropwise into boiling water, which leads to the hydrolysis and get ferric hydroxide sol. So these are the chemical reaction. And then we have another reaction, another method, which is called electrical disintegration. Critical missile concentration, I have told you 3 times, beta. This is the minimum concentration that we must have for the missile to be formed. Below that concentration, missile is not going to be formed. Below that concentration, it's simply the pure solution. Yes, Ashutosh, I am going to teach online on Unacademy. As yet, I don't have any kind of offline assignments. Okay. So let's get along with electrical disintegration. Okay. Electrical disintegration is called Briggs arc method. Briggs arc method. Now, this Briggs arc method can be used to form, there are 2 conditions of the substance which we make the colloids using the Briggs arc method. The first condition is it should be a good conductor of electricity. It must be a good conductor of electricity. So we can't make sulfur colloids using Briggs arc method. Okay. We won't be able to make any of the other iodine colloid for using Briggs arc method. So Briggs arc method cannot be used for making the colloids of the substances which are not good conductors of electricity. Second, it must be unreactive. We won't be able to make the colloid of sodium or potassium for that matter. We would be able to make the colloid of silver. We would be able to make the colloid of graphite. We can make the colloid of gold or maybe copper. Those are the inert substances which are not going to interact with water or the dispersion medium at that given system. So that should be unreactive. Then only we will be able to use the Briggs arc method. When you talk about the Briggs arc method, we have the 2 electrodes made of the substance of which we are trying to make the colloid. And then we pass high voltage. A spark is generated. That spark is, what it does is it does the spot heating. Spot heating, that is, this metal is heated at this point and it is heated to such a high temperature that it actually evaporates. Now it is surrounded by ice. That means the entire system is extremely cold. So the moment this metal evaporates, it condenses. And when it condenses, the particle size is not too small, it's not too large, so it does not go into the suspension range, it does not remain in the solution range, it goes to the colloidal range. Is this clear? Clear? So that is what we have as the thing called the Briggs arc method. Okay. Ananya, the ice bath is required in this temperature because when we put the electrodes and pass a high voltage, that arc generates a lot of heat. You can just imagine the heat being generated is enough to evaporate the metal. So if we don't put ice, then in that case, the entire system is going to start boiling. Is it clear, Ananya? So that is why we need ice around it. And we need to condense the metal very fast. We don't want it to escape out in vapor form. Is it okay? So that's a spot cooling. That is why we need the ice bath. Is that clear? So that is what we have as Briggs arc method. We have also talked about what the limitations of Briggs arc method are and what is Briggs arc method. Now we get along with peptization. Peptization is a method by which we convert a fresh precipitate into a colloid. Clear? That is what we term as peptization. The fresh precipitate is converted to the colloid. Any kind of confusions here? I've got only 29 likes. Where are the other likes? The substance which we add to convert that fresh precipitate into the colloid is called the peptizing agent. Is that clear? So we have something called the peptizing agent. Clear? Fine. Many a times the substance that we have added to create the colloid itself works as a peptizing agent. Most often this peptizing agent is ionic substance. Peptizing agent is ionic. It's an ionic substance. Should we use the word solution? I would prefer to use system. What are the properties of colloidal systems? Talking about these properties, one of the property is what we call as the Tyndall effect. What is Tyndall effect? Tyndall effect is the capacity to make the path of light passing through it visible. Now, when we talk about the Tyndall effect are shown by two kind of substances. One, colloids. Yes, the colloids show the Tyndall effect. And second, suspensions. Yes, suspensions show the Tyndall effect. Now, what exactly would be the difference? In the case of colloids, the particles themselves are not visible. The path of light becomes visible. While in the case of suspension, not only the path of light becomes visible, the particles also become visible. You will be able to see the particles. So that is what we call as the Tyndall effect. Clear? Colloids and suspensions both show this effect. And then comes the thing called the Brownian motion. Now please remember, Brownian motion is not the property of the colloids. Brownian motion is the property which lets the colloid remain stable. It is necessary for the stabilization of the colloid. Now, what is the Brownian motion? Let us say we have a low mass particle suspended in a fluid. Fluid, it could be gaseous, it could be a liquid. The substance which is capable of flowing is termed as a fluid. Now, the fluid particles, they bombard this suspended particle, and if the suspended particle is in relative mass with the particle striking it, then in that case, this suspended particle will start showing the motion. And then we are going to reach the purification of colloidal system. Still, the class is not over. Class is still going on. Okay. Now, these particles of the fluid are moving due to the tiny temperature fluctuation within the system. And because of that, they may randomly strike the dispersed particle. When they randomly strike the dispersed particle also is going to show random motion. Once it's going to move in this direction, then it's going to move in this direction, and zigzag motion is observed. Now, this zigzag motion shown by a low mass particle suspended in a fluid due to the constant bombardment of the fluid particles on its surface is termed as Brownian motion. Now, here, this is a peculiar combination of chemistry, physics, and biology, because this kind of a motion was observed by Robert Brown when he was observing pollen grains suspended in water. He found that pollen grain was actually moving randomly. He was not able to focus it. So he thought that pollen grain, being a living particle, was somehow kicking in water. Now, this motion was called the Brownian motion, but later on it was observed that you don't have to have a living particle to show the Brownian motion. You simply have to have a low mass particle. The mass of the particle should be similar to the mass of the dispersion medium particles. Is that clear? So that is what we call as Brownian motion. And Brownian motion plays a very important role in the stability of the colloids. As you can very well see that if you are trying to move your hand down, you would feel more air is going to strike at the bottom of your palm. That is the side facing towards the motion. Clear? So you can simply say that particles, the gas particles, are trying to kick it up. And that's what happens with the colloidal particles. They are being kicked up. Is this clear? Is that clear? So that is what we have as particles. Now, these colloidal particles, they are very peculiar. They always have some charge. So not only the Brownian motion is something which is stabilizing the colloids, it is even the charge on the colloids which is stabilizing the colloids. That is not allowing the colloidal particles to join together to go into the suspension range. Is this clear? Then we have electrophoresis, which is responsible to find out the charge on the colloidal particles, and then we have coagulation or precipitation that is going against the colloids. So let's talk about the Tyndall effect. Tyndall effect is strong beam of light is passed through the colloidal sol placed in a dark place. Now, here I can show you the colloids, the Tyndall effect. Hope so. The light is not too bright and you will be able to see the Tyndall effect. Yeah. Here. Can you see the glow in my finger? Now, the glow in my finger is because of the Tyndall effect, because the blood is a colloid. Is this clear? So I believe this is what we have done so many times. If the light would have been a little lower in this particular studio, then you would have been able to see the Tyndall effect. Okay, still it's visible. I can see that. Okay, the path of the beam of light gets illuminated. Okay, so what are the conditions? The diameter of the dispersed particles should not be much smaller than the wavelength of light. If it is too small, then in that case, the path of light would not be visible. Okay. And here we see that the properties of the dispersed phase and dispersion medium should differ a large. And here comes the fact that lyophilic colloids show a lower value of Tyndall effect and lyophobic colloids show a higher magnitude of Tyndall effect. Clear? More is the difference between the nature of the particles, more Tyndall effect would be seen. Is this clear? So that is the example of Tyndall effect. Oh, I have just given you the answer. Could you just mark the answer? Tell me the answer. What would be the answer of this particular question? Tyndall effect will be mainly observed in lyophilic colloid, lyophobic colloid, true solution vapor. It is going to be observed in lyophilic as well as lyophobic colloid, but the maximum would be observed in the lyophobic colloids. Is that clear? Talking about the Brownian motion, if viewed under the ultra microscope, you would find the colloidal particles to be showing a zigzag motion. This is zigzag motion is termed as the Brownian motion. Now, this zigzag motion is due to, I just told you, the constant bombardment of the dispersion medium particles on the surface of the dispersed phase particles. Okay, so that's what we have as the Brownian motion. Now, to get along with the charge on the colloidal particles. Now, what happens is that colloidal particle surface, there are certain ions, they get adsorbed on the surface of the colloidal particles. Depending on the charge of ions, the colloidal particles are going to get a specific charge. It could be negative, it could be positive, and so it is going to be forming a positive or negative charged colloids. Okay. Now, this is due to the preferential adsorption of ions. The ions are going to be something which are very similar in nature to the nature of the colloidal particles. Clear? If we have iron hydroxide sol, ferric hydroxide sol, then in that case, ferric ions or hydroxide ions are going to be adsorbed depending on which of them is in excess. If we have silver chloride sol, then silver or chloride is going to get adsorbed depending on whichever of them is in excess. Okay. So that's what we have as the colloids. So here we have excess of iodide, potassium iodide, then iodine is going to get adsorbed and we are going to get negative colloid. If we have excess of silver nitrate, then in that case it's going to be forming the positive colloid because silver is going to be adsorbed on the surface. Now to talk about the properties like electrophoresis. Electrophoresis is a system in which the colloidal particles move, but the dispersion medium is not allowed to move. Now, electrophoresis is mainly used to determine the charge on the colloidal particles. If the movement is towards the cathode, it is termed as cataphoresis. And cataphoresis is going to be when we have the colloidal particles positively charged. If it is moving towards anode, it is termed as anaphoresis. That is, the colloidal particles are negative charged. Is this clear? So colloidal particles move towards the cathode, it's called cataphoresis. And colloidal particles move towards anode, it's called anaphoresis. Together it is termed as electrophoresis. Clear? Now we talk about the coagulation or precipitation. When you talk about the coagulation or precipitation, please understand the coagulation of the colloid is simple removal of the charge from the surface of the colloid. If you just neutralize the colloidal particle, then in that case, they are going to merge together to form the suspension. The charge is keeping it separate. Now, what could be responsible for removing the charge? There could be lot many methods. One is put ion of opposite charge to the colloidal particle. It's going to remove the excess charge, and the colloidal particles are going to join together to form the precipitate or suspension. Okay, so just remove the charge from the colloidal particles and they are going to coagulate or precipitate. Is that clear? So a precipitation or coagulation is going to take place if the charge is removed. The question is how we are going to remove this particular charge. And here comes the Hardy-Schulze rule. Hardy-Schulze rule simply says that if we have an oppositely charged particle having a high charge density, it will be able to remove the charge from the colloidal particle. Something like we have positive colloid, then we have to put a very high charge negative charge density. Something like we have chloride, then better than chloride will be sulfate, better than sulfate will be phosphate. More is the charge density, more easily it is going to coagulate. So it is not just the charge, but the charge density which is responsible for the coagulation. Is this clear? We are not talking about the negative particles, how easily they are able to coagulate. Clear? Now it's not actually a linear graph, it's much more than that. Coagulating power is reverse of the coagulating value or flocculating value, something like gold number. More is the flocculating value, lower would be the flocculating power. Is this clear? Now please remember the question. Question is not asking you the coagulating power, it is asking you the coagulating value. So the value would be the maximum for the ion which has the least charge. Okay, and flocculating value would be the minimum for the ion which has the maximum charge, maximum opposite charge. Is this clear? Fine. So that is what we have as the entire chapter. I'm just going to push this particular PPT. We are having the iconic mega sale week. You can prepare today, prosper tomorrow. The prices are dropped. You can save up to 35% on your NEET UG subscription. Use the code AVLIVE and join with us. You wanted the schedule? 3 p.m. it's biology, 4 p.m. it's chemistry. Every day? Clear? And on Saturday, Sunday, and so many days, we have the marathon session. Just join the Unacademy app, download it from the Play Store, use the code AVLIVE and join with us. Clear? And you can go ahead with joining the plus courses. This is my page on Unacademy, unacademy.com/Anoop Vashishtha. Just go ahead, follow, join with me, be with me, so that you can get all the information about all the courses. Amritpal Singh says, आपकी आंखों में नींद दिख रही है. I don't know how you are able to see that. Okay, subscribe the Unacademy NEET Elixir channel for the best live classes. Bye-bye and thank you. We'll meet in the next class, that is tomorrow at 4 p.m. Okay, bye-bye. Take care.